Hello everyone, my name is Bidiya, having roll number 21NS0-225, going to present my presentation on the topic different kinds of magnetic materials, that is paramagnetic material, diamagnetic material and ferromagnetic material. The different types of magnetic material are paramagnetic material, diamagnetic material and ferromagnetic material. The behavior of magnetic material is different when you are applying some magnetic field to the material, and accordingly these are classified into three main categories, and they are paramagnetic material, diamagnetic material and ferromagnetic material. Before understanding the diamagnetic material, ferromagnetic material and paramagnetic material, we have to understand what is the relationship between magnetization and magnetic intensity. In magnetization and magnetic intensity, we found that both magnetization as well as magnetic intensity are a type of current. One who develops the property of magnetic field onto the normal magnet is called magnetic intensity, and the phenomena of the conversion from normal material to the magnetic material is called magnetization. We have found that the relation of magnetization as well as magnetic intensity is chi equals to m by h, where chi equals to magnetic susceptibility, m equals to magnetization and h equals to magnetic intensity. Before understanding what is paramagnetic material, let us assume a pen as a magnetic material. But how we can say that a pen is a magnetic material? The answer is very simple. If a pen is a magnetic material, there is one property called MdM. Here, MdM stands for magnetic dipole moment. If a material is having a magnetic dipole moment, then the material is 100% is a kind of magnetic material. Now here another question arises, that how we can say that there is a magnetic dipole moment. The answer of this question is also very simple. We can say that there is a magnetic dipole moment when the electron revolution are in a perfect way. If electron revolution inside a pen is in a perfect way, we can say that there is a magnetic dipole moment. If the motion of electrons are in uniform way, that means they possess perfect magnetic dipole moment. And when there is not the uniform way of electron motion, we can say that there is a random motion of the electron, or they are not having any kind of magnetic dipole moment. According to the motion of electron in a molecule, there are three main categories: paramagnetic material, diamagnetic material and ferromagnetic material. So now I am going to discuss what is paramagnetic material. So the definition of paramagnetic material is when we are keeping paramagnetic material into the external magnetic field, then it will not oppose that field, but it will accept the field. So we can clearly see in this figure paramagnetic material like external field को बीच में राखेको छ, and inside the paramagnetic material field line goes from south to north, whereas normally field line goes from north to south. So north बाट जाँदै गरेको field लाई चाहिँ त्यो paramagnetic को left end मा south भएको कारणले गर्दाखेरि त्यो नर्थ बाट आएको फिल्ड लाइनले चाहिँ आफूपट्टि एट्र्याक्ट गर्छ. it is happening because of the arrangement of the molecule, because of the magnetic dipole moment which are present in the material when we are providing some external magnetic field to paramagnetic material. So let us discuss the characteristic of paramagnetic materials. So our first characteristic are: on keeping the substance into the magnetic field, the material is less magnetized in the direction of external field. Second one, density of field line is more. So inside the paramagnetic material, the density of field line is more, because magnetization of field lines which are outside the material gets attracted inside the material. This means field lines are very closer inside the material. Third one, chi-m is positive and its value is small. Fourth, field lines are attracted with magnet. Fifth, when a rod is suspended in a magnetic field, then it gets arranged parallel to the field. So अगर हामीले कुनै अब रड लाई चाहिँ त्यो म्याग्नेटिक फिल्डमा राख्यो भने चाहिँ रड चाहिँ जसले चाहिँ प्याराम्याग्नेटिक मटेरियल रड चाहिँ प्याराम्याग्नेटिक मटेरियल छ भने त्यसलाई चाहिँ हामीले म्याग्नेटिक फिल्डमा राख्यो भने चाहिँ इट अरेन्ज प्यारल टु द फिल्ड, किनभने नर्थले साउथलाई एट्र्याक्ट गर्छ, त्यसले गर्दाखेरि यिनीहरू प्यारल अरेन्ज हुन्छ. So sixth characteristic is chi-m is inversely proportional to the temperature. Temperature बढ्यो भने chi-m पनि बढ्छ. So the example of paramagnetic material are calcium, aluminium, sodium, oxygen at standard temperature pressure. Here is a figure of paramagnetic material and a diamagnetic material. Here we can see that in a paramagnetic material, field line gets attracted, whereas in diamagnetic material, field line gets repelled by the material. Paramagnetic material. Paramagnetic material is a type of material which do not oppose the external magnetic field but accept external magnetic field. And diamagnetic material are those type of material which opposes the external magnetic field. When we are keeping diamagnetic material into our external magnetic field, then there is a less magnetization. If there is a magnetization, it has happened to be less magnetized. So now we are going to discuss characteristic of diamagnetic material. It is less magnetized in the direction opposite to the external field. Second one, field line is less. Third one, chi-m is negative with small value. Fourth one, get repelled by a magnet. When we place a rod made of diamagnetic material inside the magnetic field line, it gets arranged perpendicular to external field. Another one, chi-m changes with temperature. Example of diamagnetic material are gold, silver, water and bismuth. We have already known what is paramagnetic material and diamagnetic material. Now we are going to discuss what is ferromagnetic material and its characteristics. Ferromagnetic material are those type of material which accept all the external magnetic field line, which when we are keeping this kind of substances into the external magnetic field. We know that in the construction of galvanometer, the soft iron core of galvanometer is of ferromagnetic material. So now we are going to discuss characteristic of ferromagnetic material. First, more magnetized in the direction of magnetic field. Second, field line is more. Third, chi-m is positive with more value. So in the paramagnetic material, chi-m is positive but with less value. In diamagnetic material, Chi-M is positive. Chi-M is negative with small value, but here Chi-M is positive with more value. Another one, strongly attracted by a magnet. When we place a rod made up of ferromagnetic material inside the magnetic field line, it arranges in a parallel way. Here Chi-M change with temperature, but in a complex way. Here is a figure of ferromagnetic material. Inside a ferromagnetic material, there are number of departments. In each department, field lines are placed in a particular way. When we place ferromagnetic material inside a magnetic field line, it gets arranged in the way of magnetic field line, which helps this material to get more magnetized in the direction of the field. Here field line is also more in the direction of magnetic field line. Properties of paramagnetic material. The properties of paramagnetic material are: these substances have relative permeability μr greater than 1, and Chi-M is positive. The susceptibility decreases with the rise in temperature. Next, in an external magnetic field, these substances get magnetized in the direction of the field. Hence, they move from weaker to stronger part of the external field. If they suspended freely, they set themselves parallel to the field. Example: calcium, aluminium, sodium, and oxygen at standard temperature pressure. Properties of diamagnetic material. The properties of diamagnetic material are: there are no atomic dipoles in diamagnetic material because the resultant magnetic moment of each atom is zero due to paired electrons. Number 2, diamagnetic materials are repelled by a magnet. Number 3, the substances are weakly repelled by the field, so in a non-uniform field. These substances have a tendency to move from a strong to a weaker part of the external magnetic field. 4. The intensity of magnetization is very small, negative, and proportional to the magnetizing field. Magnetic susceptibility is small and negative. 6. The relative permeability is slightly less than unity. Properties of ferromagnetic material. The properties of ferromagnetic material are: number 1, the value of μr and Chi-M of this material are very large. Number 2, they get strongly magnetized in the direction of the external field, and so they are strongly attracted by the magnets. Number 3, they set themselves parallel to external field if suspended freely. 4. The material exhibits the phenomena of hysteresis. Number 5. As temperature increases, the value of Chi-M decreases. Above a certain temperature, known as Curie temperature, ferromagnets become paramagnets. Examples of ferromagnetic material are iron, cobalt, nickel, etc.